So let's go ahead and create the function to place n number of queens in given board. So let's call this saveTheQueens, and here let's pass the board. Board will be a matrix or a 2D array, and here we will pass the column index and n is the length of the board. Now we're going to take a for loop to cover all the rows. So for let I is row is starting from 0 and it goes till n and row plus plus. Now the first thing we need to do is to check the constraints, right? So first step is checking if the current cell is safe for the placement or not. So here we will create and call the function isSafe. If this function returns true, then we will place the queen at this cell. So board row column, and let's mark the cell 1, that is we have placed the queen here at the cell. Now let's create this function isSafe, and here in this function let's pass board row column and n. So row column and n. Now let's create this function isSafe. When it is safe to place the queen at the current cell, it is when the current queen placement is not getting attacked by any queen already placed on the board, right? So for current column, all the already placed queens will be present at the left of the current placement, right? As we're gonna go column by column in each row. So we need to check only in the left to the current column. Now talking about the rules, a queen can be attacked by another queen placed horizontally on the same row, right? So let's do this. Let's start I from 0. Let's take I and j here as we're gonna reuse them. So let's take I starting from 0. So starting from 0th column, we're gonna go till the current column. We're gonna come till the current column to cover all the left cells. And we need to keep the rows same. So here we are going horizontally and we're checking in the left. So in this loop, if board row and I, we're keeping the row same as we're checking horizontally. If this is 1, that means there's a queen already present at the horizontal left. So here we will return false. Now the next case is if a queen is present diagonally to any queen, then the queens can attack each other. So first we will check diagonally in upper half. Only in left, as at present there are no queens present in the right portion. So in this case we will start from the current cell, that is from current row and current column. So I is current row and j is current column, and we're gonna go diagonally upwards, that is I and j both will go till 0 from the current column or current row. So I is greater than equal to 0 and j is greater than equal to 0, and we will decrement them each time. So I minus minus, j minus minus. And here we will check if this board row column, if the cell is having a queen or not. If it is 1, then there is a queen present diagonally to the current placement, and we will return false. Now we will check diagonally in lower half. Diagonally lower half and in left. So here let's copy this, and now let's paste it here. We will start from the current cell, that is from current row and current column, but it will go till n, that is I will go till n, and column will decrease, so to go till 0, right? Diagonally downwards, right? So let's increment I and decrement j, and now here we will check if there is a queen present, then return false. But if it survives all these cases, then we can consider it as a valid placement for the current queen. And here, for that, we will return true. Now, after the constraints check comes recursion choices. So for each row, we have columns as the choices. So from here, we go to the next column to find the next placement. Save the queens board and go to next column, that is column plus 1, and let's pass n here. So if going forward we keep getting valid placements while keeping up with the current one, then it will return true. Else we need to backtrack and we need to reverse the decision for the current cell. So we set the current cell back to 0. And then finally, here outside the loop, we return false. Here, let's return false. Now the base case for this is we are going column by column, so we need to stop the recursion when column reaches its limit, that is when it reaches n. So if column is greater than or equal to n, then return true from here to stop this recursion. So this is the complete implementation. Now let's create the matrix. Let's have 5 cross 5 matrix for this example. Let's create board, and here it is a 2D array, and here let's take 0, 0, 0, 0, 0, and comma, and let's copy this and let's paste it 4 times. This is it. Now let's make the call to save the queens function by passing this board. Initially the column index will be 0, and here we're going to pass the length of this board. So let's get it in n equals to board.length. So if this returns true, that means we have a solution to this problem. And if the solution to this problem exists, then we will print the board after placing all the queens on this board. Else we will say, let's do console.log, we will say no solution. So this is it. Now let's save this and let's run this in queens.js on terminal. So let's go to terminal, and here let's say node in queens, and this is the result. Here we are having 5 queens placed on this board, and none of them are attacking each other in any manner. This is exactly what we wanted.